Okay, so exam 3 for fall 21. First thing I want to know on this cart, it has a mass of 1 kilogram. It has a speed of 2 meters per second at point A, and it goes down this slope and goes through this little roller coaster. I want to know what types of energy does it have at point B. At point B, because the height equals 0, it has no potential energy. So the only energy that it has is kinetic energy. So kinetic energy is the right answer. For part B, what is the velocity at point C? That is, I want to know here. Now at part C, it has kinetic energy and potential energy. So I'm going to take the energy here at point A, which is kinetic energy and potential energy, and set it equal to the energy at point C. So that is the kinetic energy at A plus the potential energy at A is equal to the kinetic energy at C plus the potential energy at C. So that's going to be 1/2 m. I'm going to go and put in the velocity here, the speed, that's 2 squared, plus m times 10, that's g, times h, which is also 10 meters, equal to 1/2 of m times v c squared plus 10, that's g, times, I forgot my mass there, let me put that in. So my mass times 10, that's the value for g. So here I'm using g equal 10 meters per second squared times h, which is 7 meters. So my masses cancel. That's why I didn't put those in, because they all cancel out. And so this is 1/2 of 4. That's 2 plus 100 equals 1/2 vc squared plus 70. So 102 minus 70. 32, 1/2 VC squared, and so VC is the square root of 64, which is equal to 8 meters per second. All right, so that's for part B. Now at part C, it says the cart comes to a stop at E, and I want to know what is the height at that point. So over here, it only has potential energy. So I'm going to take the energy here and set it equal to the energy here, and I'll be able to solve for h. So I'm going to have 1/2 of m times 2 meters per second squared plus m times 10 meters per second squared times 10 meters, because remember, my height here is 10 meters, is equal to m times 10, that's g, times h. And I'm solving here for h. My masses all cancel. That's 4, 2 plus 100 equals 10h. And solving that for h is 102 divided by 10, which is 10.2 meters. Let's check my sig figs. We're really just keeping 2 sig figs here, so 10 meters is the correct answer. If you put 10.2, I wouldn't count off for that. Of a block that's initially at rest at the top of this inclined plane, and the surface of the inclined plane does have friction, and the frictional force that's acting on this, I say, is 5 newtons. And I want to know what energy is lost due to friction as the block moves down the inclined plane. First, I need to figure out what is this distance. This is a special triangle. It's a 3, 4, 5 triangle. If you didn't know how to do that, I guess that's the square root of 3 squared plus 4 squared. That's equal to 5. To get the hypotenuse of that triangle. And so to find the energy of this is just saying work is equal to force times displacement. And remember that work is equivalent to a change in energy. So my force is 5 newtons, that's my frictional force, times my distance, which is 5 meters. So that's 25 newton meters, or we call those joules. And then I want to know what is the speed at the bottom of the block, at the bottom of the inclined plane. Now I need to recognize that up here, I have potential energy. I know there's no kinetic energy because it's at rest. So I have potential energy at the top of the inclined plane, and then at the bottom I have kinetic energy only. So the potential energy minus the work that's done by friction, or rather, really the correct way to do this is say plus the work done by friction, is equal to the kinetic energy at the bottom. That is, the potential energy is the mass, mgh, plus the work done by friction, I already found that. And actually up here, this is a negative value because the friction is in the negative direction. I wouldn't have counted off if you didn't give that, but that becomes important here because I have a negative 25 joules is equal to 1/2 mv squared. And then I'm solving for v. Notice here that the mass does not cancel out. I have to keep that mass in there. So that's 10 times 3 minus 25 equals 1/2 of 10 v squared. That's 300, 275. I'll do it over here. 275 is equal to 5v squared. And so v is equal to the square root of 275 divided by 5. I get 7.4. Yeah, keeping 266. 7.4 meters per second. So that's the right answer here. 25 joules and 7.4 meters per second. Now let's look at this next one here. I have a collision. First of all, I want to know what kind of collision is this. This is an inelastic collision. I know it's inelastic. That is, it does not conserve energy because there's actually contact between the two objects. So since it doesn't conserve energy, it's an inelastic collision. And it's not a perfectly inelastic because they don't stick together. What is the total momentum of the system? So for B, I know the velocity for both of them in this case. So the total momentum would be m1 v1 plus m2 v2. That is to say 1 kilogram times 2 meters per second plus 3 kilograms times negative 4 meters per second. Got to keep that negative, and so that's equal to 2 minus 12, or negative 10 kilogram meters per second. So that is the total momentum. And then for C, what is the final velocity? So that's where we're going to take the momentum here and set it equal to the momentum here. So I'll have negative 10, that's just what I did in part B, is equal to 1 kilogram times v1f plus 3 kilograms times 1 meter per second. So I get negative 10 minus 3 equals v1f, or negative 13. Okay, I think that was it, right? Yeah, so inelastic, negative 10 and negative 13. Okay. Oh goodness, this is a lot like one that we just did. So I have a cart. It has a certain velocity up here, 10 meters per second. I tell you this height is 30 meters. Now I want to know what is the speed down here. Where down here it only has potential energy. Up here it has kinetic energy plus potential energy because it's moving and it's at a certain height. So I'd say 1/2 mv squared plus mgh equals 1/2 mv squared. And this is at point A, and this is at point B. At point A. Notice my masses, they're going to all cancel out. That's 1/2 of 30 squared, or 450, plus 10 times 30, or 300, equals 1/2 of VB squared. Whoops, I'm sorry. So this should be not 1/2 of 450, but just 450. It's half of 900. 30 squared is 900, so that's 750, 1500. The square root of 1500. I get 38. Let's see. Let me pause here. I must have made a mistake. Got to be really careful with this, right? You don't want to make a mistake like I just did. So I think that my problem here was I used the wrong velocity. I said 30 was my velocity, but really my velocity is 10 meters per second. So this is going to be 1/2 of 10 squared, or 100. So that's 350. That's going to be the square root of 700 is VB, and that's equal to 26. All right. Previous figure, the roller coaster has a mass of 200 kilograms. Same situation. What kind of energy does it have at point P? Well, I've already answered that question. So it's a block with a mass of 10 kilograms has a speed of 4 meters per second. It slides across a rough surface. It's traveling 2 meters. It has a speed of 2 meters per second. What is the coefficient of kinetic friction? Okay, so I have this block that's traveling across this distance of 2 meters. Initially, it has a speed of 4 meters per second, and then I'm told over here that it has a speed of 2 meters per second. So somewhere along this way, the kinetic friction has taken away energy. So I could say then that the kinetic energy at the beginning minus the work done by friction is equal to the kinetic energy at the end. That's going to be 1/2 of m times v initial squared minus the frictional force. Look, I don't know the frictional force. I'm going to make this a little bit different and say that this is mu times the normal force, and the normal force is m times g. And then that's all the frictional force, and then the distance, which is going to be 2 meters, I know that, but I'm just going to keep it blank right now. And then this is equal to 1/2 mvf squared. Now, I can get rid of all these masses. They all cancel out. So I get 1/2, let's just put in some numbers here, of 4 squared minus mu times 10 times d, which is 2, equals 1/2 of 2 squared. That's half of 16, it's 8 minus 20 mu equals 2. So it's 2 minus 8. I'll do it up here. Mu is 2 minus 8 divided by negative 20. That's 6 divided by 20, or 0.3. So C is the right answer. Okay, let's look at these statements. A car can travel 2 paths, A or B. Experiences a frictional force, so which statement is true? The car has the same potential energy at the ends of both paths A and B. That's over here. Because the height is the same, that one is a true statement. The car loses more energy due to friction over path B. That is a true statement too, because the distance on path B is bigger, and since work is equal to force times distance, then the work could be bigger too. So the amount of energy lost is bigger too. Over the first half of the 2 paths, the car has more kinetic energy on path B than path A. So we're looking at this section right here. It has a certain amount of potential energy here, and then as it goes down, that potential energy declines, but my kinetic energy goes up. So since path B has a lower height along this first half, it is going to have more kinetic energy, so that's correct. And the car is traveling faster at the end of path A. That's true too, because path A is longer than path B, so it's going to lose less energy due to friction, so it'll have more kinetic energy when it gets to the next part. So the kinetic energy here for car A is bigger than the kinetic energy due to car B, because it's lost less energy due to friction for car A. That was statement number 2. So it looks like this is the right answer. Okay, number 5, I have a spring with a spring constant of 1200 newtons per meter, so K is equal to 1200. It's on a horizontal surface, has a mass equal to 4 kilograms. And you compress the string a distance of 2 meters, so X is equal to 2 meters, and you allow it to oscillate going back and forth. I want to know what is the speed of the block when it goes through the equilibrium position. So over here is X equal 2 meters, and over here is X equals 0. At this point, it only has kinetic energy. At this point, when it's fully compressed, it only has elastic potential energy. So I would say that the potential energy is equal to the kinetic energy. That is 1/2 kx squared equals 1/2 mv squared. Notice my masses don't cancel, but I can get rid of those halves. So that's 1200 times 2 squared equals 4 times v squared. So v is going to be the square root of 1200. Which is 35 meters per second. spring requires 12 newtons to compress it by 3 meters. Since I know this is true, I can find the spring constant. That's A. You pick up a heavy box with a mass of 30 kilograms, set it on a table 1.2 meters. What work have you done? Well, the work is equal to force times distance. The force that I exert is m times g, and the distance that I cover is h. By the way, this is also our expression for potential energy. So that's 30 kilograms times g times 1.2. And that is going to be 360 joules. So B. Person applies a force. This force at a certain angle and moves it this distance, which we'll call D. Frictional force also acts, so that's this force. What total work is done? The work is the work that's done by both forces. I have F d cosine theta minus F d. I'm going to leave off the theta because here theta equals 0 and cosine of 0 is 1. So it's going to be 8 times 3 cosine of 60 minus 1 times 3. That's 12 minus 3 are 9 joules. All right. What kind of work do you do on this? That's going to be negative work. You're taking energy away from this object. What is the basic SI unit for work? That's F times distance. Remember, F is mass times acceleration times distance. That's kilograms, meters per second squared, meters again. So that's going to be this. All right, rank these from the work done on the force by the force. This one does 0 work. And then of these two, if these two forces are the same, which they are, they're both 10 newtons, this one will do more work. So from least to greatest, I would have 3, 2, 1. Consider this inelastic. Actually, this is a perfectly inelastic collision. What is the initial speed of the 4 kilogram mass? So I know that this momentum will equal to this momentum. That's going to be 3 kilograms times 2 meters per second plus 4 times V1 initial is equal to 4 plus 2 or 6 kilograms times negative 6 meters per second. It's negative because it's going in the negative direction. That is 6 plus 4V equals negative 36. So V is equal to negative 30 over 4, which is 7.5 meters per second. To the left, but I don't ask you the direction, I only ask you for the speed. You would expect that being to the left, actually, because, you know, this has a negative momentum or negative velocity to the left, so this one must be to the left. A railroad car has a mass of 2,000 kilograms traveling at a speed of 4 meters per second. It runs into a stationary railroad car with an identical mass. The two cars connect and move at the same speed. So we could think of this as a collision problem where I have two masses. This one is going at 4 meters per second. After they collide, they both combine, and now they're moving off at a new speed. And I want to know, what is that new speed? Well, here I have a momentum in this case of m times 4 meters per second. This one doesn't have any momentum. Then it's going to be equal to 2m times v. Notice the m's cancel. That's why I didn't put in the 2,000 kilograms. So v is going to equal to 2 meters per second. It goes half as fast. Which of these statements are true? For elastic, that one's true. That one's true. That's not true. That would be for inelastic. And this is not true for any collision in the universe. Its momentum is conserved in all collisions, so C is the right answer. All right, you apply a force of 20 newtons. Let's just start writing these things down. A mass of 10 kilograms over a time of 4 seconds. The initial equals 0 because it's at rest. And I want to know, what is the speed of the object? What is the final speed? I know that F is equal to delta P over delta T. That's M is not changing, so it's M delta V over delta T. That's going to be 20 equals 10, that's the mass, times VF minus 0 divided by our time, which is 4. So VF is 8. Let's see. What's the impulse? Remember, impulse is just a fancy way of saying this. So that's going to be delta mv. My mass doesn't change though, so it's just m delta v. It's 2 times the final is 3 minus negative 4. So D is the right answer. All right, it's going to be a similar problem. Car is traveling with initial velocity equal to 22 meters per second. Let's say actually, we'll take it like this. So this is our car. Just have to be careful with your signs here. It's traveling in this direction. So that's my initial velocity. So it's positive. It rebounds now at a speed equal to 2 meters per second. Because that's to the left now, it's going to be negative. And the mass of the car equals 1,000 kilograms. And I want to know what force, so this occurs in a time of 0.1 seconds. I want to know what force is exerted. So F is equal to delta P over delta T. That's going to be the mass times delta V, which is going to be negative 2 minus 22 meters per second, all over 0.1 seconds. It's 24,000 divided by 0.1, which is 240,000. Being careful here, a big mistake that people make is that they take, say, 20, take this to be 20, but you have to be careful with your signs. Basically, if you're ever having a rebounding problem, the change in speed is going to be the sum of the two numbers, not the difference of the two numbers. What are the units of change in momentum over time? Well, gosh, we should recognize this as just a force. So that's going to be kilogram meters per second squared. That is the SI unit for Newton. So that's B. Or you could say it's mv over t. That would be kilogram meters per second, 1 over seconds, which is the same. All right. Oh, where's 19? Oh, here we go. Cart is rolling along on a frictionless track. Rain is falling into the cart. That means that the mass is increasing. What happens to the speed? So if the momentum is constant, this is constant. If m goes up, that means this goes down. So C is the right answer. That was from your concept test. This one is too, I think. You have a uranium nucleus at rest and undergoes fission. That means it splits into two pieces, one heavy and one light. Which of these is a true statement? The lighter and heavier fragments have the same momentum, but in opposite directions. I think that is true. Let's see the other ones. The lighter and heavier fragments have the same velocity. Now this one's going to be going fast, and this one will be going slow. So no. The heavier fragment has the higher velocity. Well, no, I just said the opposite of that, actually. And the lighter fragment has more momentum. That's not true either. In fact, they're going to have equal but opposite momenta. I know that because up here, the total momentum was equal to 0, and so the total momentum has to be 0 down here as well. Okay, that's it.